We want to multiply these two rational expressions together, and to do that, we're going to factor everything we can, and then look for common factors. If we find them, we'll cancel them. So on the leftmost expression, there's nothing common, there's nothing to factor, so let's just write that. It'll be 9 over x minus 7 times, but in this top right, we can factor 4 out, giving us, what do you know, x minus 7 over 63. And now here's what I see. This x minus 7 is going to cancel with that one, so let's do that. But then also, you notice that 9 and 63 have 9 in common. So what I'm going to do is I'm going to divide each by 9. 9 divided by 9 is 1. 63 divided by 9 is 7. So here's what we're left with. 1 times 4, right? 1 times 4 over, and then here we have 1 times 7. So we're just going to get 4 over 7. Now this step here you could probably skip, but I just wanted to write it so you could see where everything is coming from. So we're saying now that this set of instructions can be replaced with this set of instructions, right, as long as x is not equal to 7. So we might even toss that in there. Moving on to 21, let's factor both the numerator and denominator in this leftmost expression. So that will give us, if we do this, we will get, how about a y and a y? And then for 63, I'm thinking 9 and 7 because they differ by 2. So let's go with 9 and 7. And the 63 is negative, so the 9 and the 7 have opposite signs. We'll put that middle minus sign with the bigger product. So 9y bigger than 7y. Let's put that minus sign here. So we'll get minus 9 plus 7. Over, let's see, how about y and y? 49 and 1 are 7 and 7. Let's go with the 7 and the 7. They're both going to be minuses, and that'll work, right? Minus 7x is minus 14y, and then plus 49. Okay, and then times y minus 7, y minus 9, and now you can see that this y minus 7 will cancel with one of those. It doesn't matter, either one. Just cancel one of them. And then also, this y minus 9 here will cancel with that y minus 9. And here's what we're left with. We are left with 1 times y plus 7 times 1. Right? Whenever you draw a cancellation line, there's a 1 there. 1 times y plus 7 times 1, or just y plus 7, over y minus 7 times 1 times 1. I'll put a times sign in there. So that's just going to be a y minus 7. So we get y plus 7 over y minus 7 as long as y is not equal to, now just take it back one step where you did the cancellation. 7 from here again, we need just one, so a 7 and a 9. So we're saying that this thing works as long as y is not 7 or 9. So what we're doing, remember, is taking this set of instructions, replacing it with this more compact, more efficient set of instructions, and we can do that as long as y is not equal to those two numbers. So in 22, we're making multiplication, right? This expression times this expression, so we know what to do. We'll factor everything in sight. So let's try this. In the top left, I'm going to go to blue. This is going to give us y, and I'm thinking a 6 and a 4 with a minus 6 and a plus 4. That'll give us a minus 2 and a negative 24. And in the bottom left, how about a y and a y? What do you think, 6 and 5? With a minus 6 and a plus 5. Okay, and then I can see that I'm going to be canceling those probably in the next step. Then times, what can we do here in the top right? We get a y and a y. Now I'm thinking an 8 and a 2 for that 16 because I can get a 10 out of that. They're both going to be negatives because we have a negative 10 but a plus 16. And in the denominator, how about a y and a y? Now for 32 and 1 won't work, 16 and 2 doesn't work, 8 and 4. Yeah, 8 and 4 I think is going to work for us. So let's go with an 8 and a 4. We'll go with a minus 8 and a plus 4. That will give us at minus 4. And now look to see if anything's common. The y minus 6's are common, so we can cancel those, right? As long as it's one side to another, the angle doesn't matter. These happen to be vertical, right? One side to another. Now, what else, if anything? Here's a y plus 4 and a y plus 4. Those will go. Let's cancel those. And then also, I see these y minus 8s. Those will go. And here's what we're left with. Now, we're left with a 1 times 1 times 1 times y minus 2. So that's just a y minus 2 over 1 times y plus 5 times 1 times 1. That's just y plus 5. So y minus 2 over y plus 5, and all this works as long as y is not equal to, now take it back one step. Look what's going to make these 0, just the denominators, right? 6, negative 5, 8, and negative 4. So we'll write those. We'll get 6, negative 5, 8, and negative 4. Now the negative 5 you can see from here. But we lost the 6, the 8, and the negative 4 in our cancellation. But keep in mind that here's the original. Whatever has to be excluded from the original has to be excluded from anything we derive from it, because this thing exists only when this exists. Number 23, notice we've got a division. So for the division, we're going to invert the divisor and multiply, right? We're multiplying by the reciprocal of the divisor, and the divisor is always the expression that comes second. So we're going to flip this over if you like. So we're going to write this now as x squared, I'll go to blue here. So we'll go to x squared plus 7x minus 8 over x squared minus 9x plus 8. Now all I've done here is I just rewrote the first rational expression, but now I'm going to change the division to a multiplication. So times, and now get the reciprocal of this. Just flip it over. So this is going to be x squared plus 13x plus 36 over, now what I'm going to put on the bottom here used to be on the top, so that's going to be x squared plus 12x plus 32, and now we're going to factor. So how about x and x, 8 and 1, and I'm thinking plus 8 minus 1, over x and x, and then 8 and 1 again, 8 and 1, but because the 8 is positive, both these numbers have the same sign, that's going to be that middle minus sign, so minus 8 minus 1 times, let's factor that top right, x and x. I'm going to go with 9 and 4 and get a 13 out of a 9 and a 4. They're both going to be positives. You know, that's a little bit tight in there. We can do better than that. Let me erase that. Okay, this is going to be x plus 4. That was too tight. Over x and x. Now for 32, we could try 32 and 1, that's not going to work. 16 and 2, that's not going to work. 8 and 4, 8 and 4 looks like a good combination. Let's go with 8 and 4, the 32 is positive, they'll both be positives. So what is going to cancel, if anything? I got an x plus 8 here and an x plus 8 down here, right? As long as it's bottom to top, we can cancel that. So the x plus 8s go. This x minus 1 goes with x minus 1. Anything else? Yeah, the x plus 4s are going to go. So the x plus 4s will go. That goes with that, kind of a mess. Now here's what I'm left with. 1 times x plus 9. So we're just left with an x plus 9 here. Over x minus 8 times 1 times 1 times 1. Remember, anytime there's a line through something, it's a 1, because we're canceling it out. We're dividing it out by itself. So it's going to be over x minus 8, And we're saying that this original set of computing instructions can be replaced with this set as long as, right now here come the restrictions, as long as what? X is not equal to, now follow it a step up, bring it up a step. What's going to make these 0? 8, 1, negative 8, and negative 4. So let's write those. So from the first one we'll get 8, then a 1, then a negative 8, and then a negative 4. But we have to be careful here now. Something else is going on. We got this negative 8 and that negative 4 from this denominator. Now, normally we don't have to worry about numerators, but in this case, you see this numerator here? That was originally this denominator, right? This denominator became this numerator. So in this case, whatever was a denominator, we have to consider. So this used to be a denominator. So what's going to make this one 0? Negative 9 and negative 4. We've already got the negative 4, so we just have to combine it with that negative 9. So there we go. So we have that this expression here can be reduced to this expression as long as we exclude these 1, 2, 3, 4, 5 numbers.